knock out this homework. We got 1 through 8, 15, 17 through 20, 23 through 26, and 29 through 36. 1 through 14 says solve the equations using the quadratic formula. Don't give you a choice, tells you use it. The first thing to remember when we're doing the quadratic formula is remember that the coefficient in front of here is A, coefficient in front of my second one is B, and the third one is C, that constant, right? So the coefficient in front of x squared, right, is A, the one in front of x is B, and the constant is C. Now, once you remember this, it's easy to plug it in. You write out your quadratic equation, negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. That's a lot to remember, but you'll start getting the hang of it. So now we're going to replace all the letters with the letters up here, or the numbers up here. So remember, b is negative 12. So over here we got that's going to be a negative 12, which is going to end up being a positive 12 later, okay? Over here, this b squared is going to be negative 12 squared, which will be 144 later on. And then we've got a and c. This is going to be a 1, and this is going to be 36. So it's going to be negative 4 times 1 times 36. And on the bottom, 2a. Well, there's a 1. Remember, whenever you don't see anything in front of a letter, there's always a 1 there, all right? And if there's a negative variable, then it's a negative 1. But for right now, it's a 1. Okay, so now let's go and work these out. Negative times a negative is a positive 12. Negative 12 times negative 12 is positive 144. Negative 4 times 1 is going to be 4, and then 4 times 36, it's going to be 144. So we have negative 144. Now you've got 144 minus 144, and that's going to give us the square root of 0. So 12 plus or minus the square root of 0 over 2. Well, we know the square root of 0 is 0. So that tells us it's simply going to be 12 over 2. And 12 divided by 2 is 6. This has one solution, x is 6. All right, let's go on to the next one. We have number 2 to do. Number 3, again, remember this is a, this is a negative, so this would be like a negative 1, and its constant's 1. So we've got 2 for a, negative 1 is b, and it's negative 2, or negative 1 is c as well. When we do this, remember our formula, negative b plus or minus square root of b squared minus 4 times ac divided by 2a. So we're replacing negative b with b with negative 1. So now we're going to have negative 1 plus or minus the square root of negative 1 again square, and then negative 4 times a times c. So that's a negative 4 times 2 times negative 1. Now, then we're going to have a down here being 2, so it's going to be 2 times 2. Let's figure it out. Negative 1 times a negative is a positive, so this would be positive 1. Negative 1 times negative 1 is positive 1 as well. Now we got negative 4 times 2, which is negative 8, and then negative 8 times negative 1 will be positive 8. Now inside we got 1 plus 8, and that's going to be 9. Well, the square root of 9 is 3, so now we have 1 plus or minus 3 equals 4. 1 plus 3 is 4, okay? So 4 over 4 is 4 divided by 4, which is 1. Now 1 minus 3 would be negative 2. And now that's going to reduce, because both of these are divisible by 2, to negative 1/2. All right? And you have number 4 to do. All right, so let's go on to number 5. Sorry about that. I deleted out of the PowerPoint slide. Or exited the PowerPoint slide, I should say. Now let's go with number 5. This one already kind of jumped up on me, but we got the same thing over here. Remember, we're going to have A, B, and C again. So this is going to give me A, 9 is A, negative 6 is B, and then we have 1, that's going to be C. All right, so negative 6 is going to go over here in place of B. It's also going to go over here for B squared. 9 and 1 will come over here, multiply to negative 4 in place of A and C. And 2 times A on the bottom, which will be 2 times 9. All right. Negative times a negative is a positive, so this gives us a positive 6. Negative 6 times negative 6 is positive 36. And then, let's see, we got negative 4 times 9, that's negative 36. Times 1 is still negative 36. Now we have 36 minus 36, that's 0. So now we're going to have 6 plus or minus the square root of 0. And we know the square root of 0 is 0, so now we have 6 over 18. Well, both of these can be divided by 3. So we can divide this by 1 in the form of 3 over 3. And that's going to equal 1 over 3. 6 divided by 3 is, I'm sorry, both of these are divided by 6. I'm sorry, I went to 3 when I should have said 6. 6 divided by 6 is 1, and 18 divided by 6 is 3. So the only solution is 1 over 3. All right, let's go on to, you have number 6, so I'm going to number 7. On this one again, we see that we're going to use A will be 6, B will be negative 13, C, well, look right here, we got an equal sign. And that does switch things up a bit. So just to work this, we're going to add 6 to both sides. That's going to turn this to 6x squared minus 13x plus 6. So this would be a positive 6, that's C. Negative 13 would be B. And 6 would be A. All right? I'm going to make this look more like a 6, I guess. There we go. All right, so let's go ahead and we're going to plug this into our formula now. That's exactly what they did over here. They added 6 to both sides, right? And they got 6 x squared, right? Minus 13x plus 6 plus 6. So now they're going to use the A, B, and C. My B will be negative 13. My A will be 6 and 6, so that's 6 times 6 here. And so now we're going to have negative times a negative is a positive 13. 13 squared is 169. So negative 13 squared is still 169. And we have 6 times 6, well, that's 36. 36 times 4, negative 4, would be a negative 144. Now 169 minus 144, that's 25. So now we got the square root of 25, which is 5. So this is going to turn to 13 plus or minus 5 divided by 12. All right, 13 plus 12 is 18. So that'll give us 18 over 12. And 18 and 12 are both divisible by 6. 18 divided by 6 is 3. 12 divided by 6 is 2. This would be 3 over 2. The next one is 13 minus 5. 13 minus 5 is 8. 8 over 12, both of these are divisible by 4. 8 divided by 4 is 2. 12 divided by 4 is 3. And those are our 2 possible answers. You have number 8 to do. I'm moving on to number 9. Or I'm sorry, number 15 by the looks of it. Modeling in real life, the function h equals negative 16t squared plus 26t models the height in feet of a dolphin t seconds after jumping out of the water. After how many seconds is the dolphin 5 feet above the water? All right. Okay, so there's our equation, h equals negative 16t squared plus 26t. Now remember, they're talking 5 feet. No, so y is going to be the 5 feet, and that's h right here. So we're going to put 5 here, and then we're going to solve. We're going to have to subtract 5 from both sides to bring it over. That's going to give us negative 16t squared plus 26 minus 5. Now remember, this is still going to be a, b, and c. So my b is going to be 26. My a is going to be negative 16. And my negative 5 is going to be my c. So now I have, well, negative 26 comes down. The square root of 26 is 676. Negative 4 times a negative 6 times a negative 5 gives us negative 320. Oh, sorry. Negative 320. Then 2 times negative 16 is negative 32. Well, 676 minus 320 is 356. This does not have a square root. So now we're leaving it as negative 26 plus or minus the square root of 356 over 32. So the solutions are negative 26 plus the square root of 356 over negative 32, which equals about 0.2, and it's also negative 26 minus the square root of 356 divided by negative 32, which is about 1.4. Now, so the dolphin is at a height of 5 feet after about 0.2 seconds, and again after about 0.14. And if you're wondering how that's possible, just remember we're talking about a dolphin here. So it's reaching a height and then coming back down, right? So that means at 5 feet, it could be here, right? 5 feet. So that means at 0.2 seconds, and then again at 1.4 seconds. So on our x scale, I guess this would be more like here at 0 seconds. This would be 0.2 seconds, and this over here would be 1.4. All right, that's it for number 15. Let's move on. Number 17 says determine the number of real solutions of the equation. All right, so let's go ahead and look at this carefully. If I'm looking at this, I see that I got x squared minus 6x plus 10 equals 0. I'm going to use that equation that's inside of my quadratic equation, the one that's in the square root symbol, right? I'm going to solve this first. Remember, b is going to be negative 6. 1 will be a, and 10 will be c. So in here, we've got, this is going to be negative 6 squared minus 4 times 1 times 10. Well, negative 6 times negative 6 is 36. And negative 4 times 1 times 10 is negative 40. 36 minus 40 is negative 4. The discriminant is less than 0. And we're talking about whatever's inside here is called the discriminant. And if it's less than 0, the equation has no real solutions. All right? This has to be 0 or bigger in order to have a solution. If it is not 0 or bigger, there are no real solutions to this problem. All right, let's go ahead and work this one over here. So on this one, we're going to go ahead and add 18 to both sides. So this is going to be 2x squared minus 12x plus 18. And again, we're going to put it inside there. So we're going to have, let's see, b is negative 12. So we're going to have negative 12 squared. And we're going to have minus 4 times, and this is going to be 2 and times 18. All right. We solve this just like we had over here, negative 12 squared, right? Minus 4 times 2 times 18, minus 4 times 2 times 18. Well, negative 12 squared is 144, because 12 times 12 is 144. And then negative 4 times 2 is 8, or negative 8, and negative 8 times 18 is negative 144. Well, we got 144 minus 144, that's 0. The discriminant is 0, so the equation has one real solution, just one. Remember, there will be no plus or minus, because when we get it back in our equation, let's try to remember here, we have b, right, that we're saying we're going to do plus or minus, and it's going to be the square root of 0, right? So the minute we do this, this is going to be b plus or minus 0, and that equals the same thing, just b. And that's why we'll have one solution. We won't have to add or subtract anything to the top, right? And then, of course, we're dividing it by 2a, okay? All right, in this case, it'd be another 2, so that would be b over 4. All right, so let's go ahead and move from there. Number 23 says find the number of x-intercepts of the graph of the function. X-intercepts, okay. For finding the number of x-intercepts here, I'm going to take, again, that equation that's part of my quadratic equation. Remember, this is going to be b. This is 1 is a, and then negative 1 will be c. So over here we've got b squared, it's going to be 5 squared, and that's going to be minus 4 times 1 times negative 1. So we've got 5 times 5 is 25, and negative 4 times negative 1 is 4, and now we have 29 plus 4, which is 29. All right, the discriminant is greater than 0, so the equation has two real solutions. So the graph of y equals x squared plus 5x minus 1 has two x-intercepts. Two solutions gives me two x-intercepts. All right, number 25. This time negative 6 is going to be our a, 3 will be b, negative 4 will be c. Then we're going to plug it in over here. When we do, we're going to have 3 squared minus 4 times negative 6 times negative 4. Well, 3 times 3 is 9. And let's see, negative 6 times negative 4, that's a positive 24. 24 times negative 4 would be negative 96. So now we have 9 minus 96. That's going to give us a negative 87. Remember, it has to be 0 or bigger. So the minute it was less than 0, the equation has no real solutions. So the graph has no x-intercepts. It's not going to cross to x. So what they're basically saying is you're going to have a standard quadrant here, okay? This is minus, so negative. So we know we're going to get a loop like this somewhere, right? And so when we're finding this, we're going to be going ahead and getting something that doesn't go into the graph. It's either going to be here or over here, but it will not go through x, okay? All right, we got 24 and 26. Moving on. 29, solve the equation using any method. Explain your choice. All right, so if I'm looking at this, I see that I've got no even number here. I'm going to say the equation is not easily factorable because there's no even number. I don't see a way where I can get, let's see, 10 times 4 and then get 40, that's going to be 4 and 10, not going to give you 13. So it's not easily factorable. And A, okay, is not equal to 1. It's negative 10. So we're going to use the quadratic formula, right? This is our fail-safe. So when we do this, first I'm going to add 4 to both sides, right? Or subtract 4. Sorry, we already had a positive 4. We're going to subtract 4 from both sides. That's going to leave you negative 10x squared plus 13x minus 4 equals 0. And now we're going to put this into our quadratic equation. Remember, this is going to be A, B, and C. So we're going to take 13 in place of B, and that's going to give us a negative 13. And then 13 in place of B squared, which would give us 13 times 13. Oh, sorry. There we go. 13 times 13, that's 169. And then we're going to replace A with negative 10 and C with negative 4. And here's the other A. Now I've got negative 4 times 10. I'm going to make this easy. Negative 4 times negative 4 is positive 16. 16 times negative 10 is negative 160. So now I got 169 minus 160. That is going to leave me with 9, right? And of course, 2 times negative 10, that's negative 20. The square root of 9 is 3. Now I got 2 possible answers. I know I got negative 13 plus 3. That's going to give me negative 10. Negative 10 over negative 20 is 1/2. Or I can take negative 13 minus 3, which will give me negative 16. Negative 16 over negative 20, both of these are divisible by 4, right? Actually, negative 4. So negative 16 divided by negative 4 is 4. Negative 20 divided by negative 4 is 5. All right, that was number 29. 30 is yours to do. You got 31 over here. X squared plus 6x equals 5. The equation is not factorable, okay? Which means if I go ahead and do, let's see. If I was to subtract 5 from both sides, that's going to leave me with x squared plus 6x minus 5. Now, the reason they said it's not factorable is 1, remember that coefficient in front of here times this number, that's going to give me negative 5. So I'm looking for 2 numbers that give me negative 5, but will give me 6. There are no 2 numbers like that. Think about it. Negative 5 can be made by taking 1 and negative 5, or 5 and negative 1. That is it. And when I add these, I'm either going to get a negative 4 or a positive 4. So that's not factorable. And that's why we're going to complete using the square method. All right. So in the square method, and that's because 6 is even here. Okay. Yeah, B is even. So that tells me I can go ahead and take, let's see, remember that formula was 2, let's see, 6 over 2, and then we're going to square it, right? And that's going to give us 3 squared, and 3 squared is 9, right? So right here was our, this is where we took 3 squared, right? And 3 squared is 9. So we're adding 9 to 5 to get 14, right? And then the perfect square here, remember we're squaring these things here. So, and then we're using the sign that's in front of this. So we got x, right? Squaring out x squared is x, and then the plus sign, and then 3 squared, that's going to be 3. So now we got x plus 3 squared equals 5 plus 9, which is 14. Now we're going to go ahead and get the square root of x plus 3 squared and of 14. So the square root of 14 is really just plus or minus 14. There is no number that multiplied to itself will give us 14. Square root of x plus 3 squared is going to be x plus 3. So now we have x plus 3 plus or minus square root of 14. Remember, we're going to subtract 3 from both sides so we can get x alone. And that means we're going to have 3 plus the square root of 14 and 3 minus the square root of 14, right? Well, actually, it's a negative 3 plus the square root of 14, or negative 3 minus the square root of 14. All right, number 32 zeros to do. Next is 33. So solve the equation using any method, okay? Can I square this one? Well, I got 1 times negative 12, right? And that would give me negative 12. Can I get a negative 12 and then get 1 for an answer? Well, I could take, let's see, 4 times negative 3, right? That would give me negative 12, and 4 minus 3 would give me 1. So I could factor this one out pretty easy. That's the way I'm going to do it. The equation is easily factorable, so solve by factor. There we go. Remember, when we factor it out, this is going to become x minus 3. This will become x plus 4. That's how they got these two here. And we're going to put it all to 0. Okay? When we do this, we're going to have x plus 4 equals 0. Okay? And then we're going to have, remember, we're solving both of these for 0, right? And then we're going to subtract 4 from both sides. And 0 minus 4 is negative 4, so x is negative 4. We also have x minus 3 equals 0, and we add 3 to both sides to give us x equals 3. So that's our solutions, negative 4 and 3. All right, let's go. You got 34 to do. I'm going to do 35. All right, if I'm doing this one, first thing I've got to do is, see, I'm going to minus 16 from both sides. That's going to give me x squared plus 6x. And then 9 minus 16, well, since my signs are different, I find the difference. I take the big number minus the small number and keep the sign of the big number. So that'd be a negative 7. All right. So now, can I get a positive 6 from getting a negative 7? Let's find out. Well, I could get a, let's see, negative 7 can only be made by doing negative 7 times 1 or negative 1 times 7. And 7 minus 1 is 6. So I'm thinking this is factorable. They're saying also that the left side is a perfect square trinomial. So we could use the square root method. Okay. I think we could have done either way there. And using the square root method, we're going to go ahead and take, see, we got x squared, and remember we're taking 16, we're looking for what squares out of this, right? So we got 6x plus 9, sorry, this is going to be, yeah, 6x plus 9. So I can go ahead and say that 3 times 3 is 9, right? And I can say that 2 times x times 3, that's going to give me 6x. And then that's going to leave me x plus 3 squared equals 16. And for those who didn't follow along, here, let's work it out over here a little more in detail. So there's my pen. Okay, so what they're saying is on this side of x squared plus 6x plus 9 is a perfect square trinomial, right? So what they're saying is that if I took, let's see, 1 times 9, that's a factor of 9, right? And that I could take 3 times 3, right? And that would give me 9, but then add up to 6. So I can do that because also 16 is also a perfect square. So by doing this, they're saying that they're saying x plus 3, and then x plus 3 over here, and that gives them that perfect square. Since it's being multiplied twice, we can say x plus 3 squared. And that's what they got right here, x plus 3 squared, okay? So if that better explains what they did over here, then good. Then they took 16 squared, right? They squared both of these, right? And the square root of x plus 3 squared is going to be x plus 3. The square root of 16 will be plus or minus 4. So now we're going to subtract 3 from both sides to get x by itself. And that gives us x equals negative 3 plus 4. Well, negative 3 plus 4 would give me 1. And then negative 3 minus 4 would give me negative 7. Now, if you're wondering, Mr. Mendez, could you have done it the way you originally said? Well, look right over here. Remember, when I brought that over, I got these two here as the only numbers that would give me a positive 6. And this would have been x minus 1 and x plus 7. And then when we solve for x, we would have had x minus 1 equals 0. And when we solved it, we would have got x equals 1, which is exactly what I got here. And when I solve this other side for x plus 7 equals 0, I would have subtracted 7 from both sides, which would have given me x equals negative 7, which is exactly what I got here. So sometimes there is more than one way of doing it, right? All right, let's move on. Oh, that was my last one. Okay, the rest were for you to do. Hope that you're able to solve them. Have a great night, and I'll see you in class.